Hi everybody. So it's been a while, but ready to make a new video on Spring Data. Spring Data is something which I use on a daily basis on the job, and a very useful skill for you to know if you're going to be dealing with Spring much, so I figured I'd pass this knowledge on to you at this point. So we're going to be using Mongo today as our database of choice. So let's start out by looking at where you might get a Mongo data set if you don't already have one. I'll show you the one that I'm using right now, which came off of GitHub. Asler Hakan has got a page called MongoDB JSON files. If we go into the data sets, he's got a whole bunch of them here, and I chose the restaurant data set, which is a JSON data set that I've brought into Studio 3T. And in here, if we were to go ahead and run a find all query on this data, then there is a total of 2,548 entries, so a pretty good sized data set. If we look at some of this data, we're going to find we have what looks like a restaurant set, and it looks like a typical Mongo database. So you have a simple document, no subdocuments, no arrays or anything, which is perfect for teaching Spring Data, because you can focus on the points at hand and nothing else. Now, with this data comes a little bit of trickiness because the ratings sometimes are integers, and sometimes you will have rating not yet rated, in which it is a string. This will create a peculiar difficulty when it comes to coding it in Java, giving us a decision between whether to represent this as a string or as an integer or as both, using an object and then casting accordingly. For our purposes today, we're just going to use strings only when we start to work with the data, because it's simpler and you can always cast to an int from a string very easily should the need arise to do calculations. But in the context of a typical REST API where you're simply displaying data from a database with a get, post, delete, and put, you're not really going to need to do that much with the numbers per se. So let's go ahead and get started up here. I've created a basic project in IntelliJ to start with. I've already laid out the files we're going to need, but didn't put any data in them. So we're going to start with our basic main controller, which is the same as the ones we've seen before. We're going to annotate it with REST controller. That is, it's a headless controller. It has no views. And then we're going to add in a couple request mappings in here, just dummy ones. So value equals root, request method equals get. And then we're going to fix that import. And it wants me to put in a function definition, of course. So we're going to put in a list of type restaurant. Find all. And we're going to return new list restaurant. And it's going to complain there's no such thing as a new list, there's only new array lists. So we'll just return an array list. It's going to complain with the diamond notation, so we'll get rid of that as well. There, that's a function that will work, but it won't do anything useful. I'm going to create a second request mapping called value equals name. And you may have seen this notation before in JavaScript. It really is the same thing. What I'm going to do here is public restaurant find by name. And then we're going to go at, with the new annotation here, path variable, string name. What path variable does is it says this is in the path. It's not a header argument. It's not a question mark thing. You're simply going to put slash and then the value in, and it's going to read that and then use it. So we're going to go return new restaurant. There. And that'll be that for now. This will just be a dummy app that does absolutely nothing. I'm going to run it, make sure it works. While it's running, I'm going to go back here. I'm just going to go ahead and refresh it. Pretend you didn't see all this. We just have an empty list. Put a name, some name in. We have an error because it can't find a converter for restaurant. That's fine. It's getting a null value. That's good. We'd expect that. Because if we go back to our program, we'll find there is no definition for this other than just a simple class. And for a repository, we have nothing here either. So what I've done is I've created a model package that'll hold our data models and a repository package that'll hold the repository that maps. The first step we're going to need to do is to map this using the Spring Data Object Relational Mapping, or ORM. So we need to figure out what the structure of our class is with regards to Mongo. So what I'm going to do here is I'm going to go ahead and shrink this down a little bit to where we can go in and hold Mongo side by side to look at the structure of our project. By doing this, we can then see the field names and just start writing them down. So the first thing we'll have to do is realize the name of our collection is restaurants. We'll go document collection equals restaurants. Fix our imports. It's using the MongoDB document import. And now this is where things start to get a bit on the interesting side, but not at all non-trivial. We're going to use an annotation for ID. And then we're going to use an object ID from the bson types, which is identical to the object ID we see in the type in Mongo, and call this ID. Next, we're going to put in a public string URL, because we can see URL is a string, as is every other type in here. But remember, the not yet rated was also an integer, but we're going to call it a string for the sake of argument for now, because integers can convert easily to strings without any kind of implicit mapping. So public string address line 2, public string name, public string outcode, public string postcode, public string rating, public string type of food. Now, you might be asking at this point, what in the world are you doing, Azadi? You're sitting here and you're putting in public variables in a class object. Well, one of the beauties of what Spring Data does is it allows you to map the data if it knows about the public variables from the actual class definition using reflection. So since we're not going to be directly manipulating these variables the same way we might with a traditional object where you're worried about somebody from the outside changing it, we're handing the control over and using an inversion of control pattern for Spring, which tells it, you're allowed to go ahead and find this and use it as you see fit, and then map the database to the Java object. Now we face a problem here, and that is inside of the database we have capital URL, but here we want to use the traditional Java camel case of URL. It's not a constant, we don't want it capitalized. We have this nice annotation called @field, provided again by the Spring MongoDB data framework. And we can say this field maps to capital URL. The same can be done for address line 2, which has spaces. We can put it in exactly as it's stated in the database, but then give it a name. There is a similar annotation for the Jackson framework called @JSON property that will do the same thing. But I prefer to stick with what I can within the framework I'm using rather than using outside ones, because then you deal with versioning conflicts and other problems. So once we fix these three together, we're all fine. Typically, you're not going to want to see the ID from Mongo. It's a security concern as well as just noise. Fortunately, Jackson Data Mapper gives us an annotation called JSON ignore, which means that we can act as if this doesn't exist. It'll do the lookup based on the ID, but then it'll never return it back to us in the final product. So that's what we have to do to wrap together the part of the model. What we have is something that looks exactly like what we see inside of Mongo, and it's ready to roll. Going back to the project level now, we have a restaurant repository. We have our application class, and we have our application properties. I've already filled in our application properties to save time and noise in this video, but I'll explain it now. You can add in any property that you like, user-defined or otherwise, but Spring Data gives you already the MongoDB helpers that map to what you would do if you were to map it by hand. And you can set the host, in our case is localhost, the port is 27017, and our database is called Spring Data. As you can validate here, it's called Spring Data. The collection is restaurants. Now if we go to the repository class, we have just a simple interface. We're going to, once again, use annotations, as is the nature of Spring, and annotate this as a repository. A repository is a component, just like a controller or a service. It just tells us it's going to be an ORM mapping. It doesn't have to tie in any way to Mongo or to SQL or to Neo4j or Cassandra or any other database. It simply says this is an object relational mapping. Now what this will give us for free is this very nice feature. We can go list of our model and then say find all. And it will just work out of the box because it knows that this is a repository. We're going to take the step of telling it it's a Mongo repository at this point and tell us it's a Mongo repository that takes advantage of our model and passes a string. The magic of Spring comes in that it knows nothing about our implementation, and yet we can still query fields inside of our database. Find by. Remember that we have a name field. We're going to start typing in NAM. There it is. Find by name, string name. This will work with our second property in the controller for find by name. So we go back to our controller now. We can use again the inversion of control pattern and auto wire our repository. Now that this is auto wired, we can replace these boilerplate code pieces with an instance of our repository, find all, and an instance of our repository with find by name. There's one last piece we still have to do, and that is going to our application level and enabling Mongo repositories. So we're going to do that now. This is your basic main method like you'd see in any Java program, except it has this Spring Boot application annotation at the top telling it's a Spring Boot application. If we type enable Mongo repositories and we tell it the base packages equals our base package, springboot-data-mongo.repository, because that is where we're hosting our repository at. There's the base package and then a repository. If we had multiple repositories, we could go ahead and give those definitions here with a comma in between and put this in curly braces. But we only have one today, so we're just going to leave it that way. Now, if we were to restart our program, we should be able to do queries on the database and see live data come back. So let's try that out. Here we go, it started the project. So now, if we go here and we hit the endpoint again, we can see it's taking some time. It loaded the data, and sure enough, there's our data from the database. So now suppose that we would like to try to look up @indian.com as a name. Remember, we have a path variable, @indian.com. There's the entry. And just to convince you that that's actually really what is going on, we're going to go into Mongo now, and we're going to go and type in name @indian.com. And sure enough, we get one record, and it matches what we just had up, minus the ID field, because we JSON ignored the ID field. Similarly, we can work with post variables and make instances of them. So let's do that really briefly here in our main controller. If we would like, we can do a request mapping, value equals just flat, method equals request method dot post, public string add new restaurant. We're going to pass in a restaurant object. Now we're going to create a new restaurant object. Just like we would any other object in Java. Instead, we're just going to say, just call it restaurant. Then we're going to go to the repository, .save, the new restaurant. Similarly, we could go ahead and just pass this in, but suppose we wanted to do some sanitization on it, then we could go new restaurant.address equals some sanitized address and do work on it. And when we're finished, just for good housekeeping, we want to return maybe a return success. Now this requires the use of a tool like Postman or otherwise, so that you can actually validate that it worked and also pass your body data in. In addition, you'll have to give the annotation request body for it to know that you're passing it into the body. The request body is another simple product of the web bind annotations. We have a dot star here, but the dot star does roll in the get, the post, the delete. For one last piece of good housekeeping, we'll discuss how you would delete using Mongo. So we'll use the ID method equals request method dot delete. Public string delete restaurant. Path variable string ID. If we go this way, we can go delete. We have to first find the object. So we'll put in restaurant equals this repository dot find by ID, and it's got an optional, so we've not implemented the method yet, which is just fine. We're going to implement that method momentarily. If we control click into the repository method, we can then add another. And this is a generic list by T, so it's not going to recognize unless we tell it what we're doing. And it's complaining. Find by ID, attempt to use incompatible return type. CRUD repository. So maybe what we should do is just do another find by name here. Just leave it as a find by name, because the find by ID has a specific meaning and has to be overridden by hand. Not a great idea on my point for a short video. This video's already got longer than I would like it for it to be. So we'll just change this to name. We'll change this to name. And now we can go ahead and just put name right here. And then that will delete the restaurant. We can return success. And that's that. And then if we were to go into Postman and run a post or delete, and then add the name into the variable, then we're going to be able to delete it and check in Mongo that it actually worked. And that is all I've got for this video. You can do all kinds of interesting combinations, sanitizations, etc. using this pattern. But this really is the basic gist of how you use Spring Data with Mongo. So thank you for watching and have a great day.